Okay, now we really go into the main business of this course, security and architecture. Okay. Now, I strongly believe that every course, at least in the systems side, from computer organization, computer architecture, operating system, compilers, all should be taught from a security and networking hardware, at least the part, should be taught from a security point of view. Then only it makes sense for the next era. Okay. So, all the other stories are already done. I think we should, the way we should form the next generation syllabus for should be that all the other stories you should learn from all video lectures which we host in NPTEL and other things, and the real course that we teach in a curriculum should be more focused towards security, right, and that makes the at least at a postgraduate level, so that we address one of the most important problem, and we need several lakhs of engineers to handle these issues, and we produce in thousands. So, there is a big gap, and there is a lot of market value also for this. So, I think and it is only of reason that people even talk at even big management decisions in bigger organizations, especially financial organizations. The need for information security is slowly coming in. They are realizing the need for information security, and so within next 4 to 5 years there will be a huge demand. So, there will be presentation to top managements where they start asking you about intricate questions about security, right, intricate questions about hardware. So, they will be forced to learn all these things the moment the systems take some hard punch in terms of security vulnerabilities, correct. So, if you start feeling the pinch, then you start reacting, okay, and that will start happening, and that is my opinion. So, this course becomes extremely important from that point of view, and again as I told you when in the previous session, that there is no connection between what was the root cause and what was the actual action, that effect that you see. The cause and effect relation is really far spread. Similarly, here also I will be teaching lot of computer organization, I will bring in some security point of view, but for you to realize where it is going to be really useful, you have to go through all the 4 courses, and then finally you will realize where you can use it in full perspective, right. So, this deep dive that we are going to do into architecture today will be finally appreciated when you start building or writing some secure solutions or start building secure engineering. At least for you to appreciate why certain problem has occurred, right, that itself you need lot more intelligence, and there also you need to diagnose a security vulnerability, you need to have this much amount of architectural understanding. Okay. So, with this I will start here. All the issues that I have talked, we need to find a solution, there is no going back on this, and that solution will be certainly a collective effort of architecture, operating system, compiler and application developers. Okay. So, what we are going to do in this course is we are going to discuss what is the role of the architecture, what should be the structure in that architecture, what are the roles and responsibilities of the architecture in this collective effort. The subsequent courses we will see what is it that the operating system should do, what is it the compiler should do, and what should the application developer should do. Okay. So, we will have 4 more courses in that series to complete this. Okay. Now, this architecture is like the body, security is like the blood, correct. So, let us take this imaginary situation that you see on the slide. Suppose we existed for 4 decades with just body and no blood, and suddenly we want to fill up with blood and make ourselves immune, right. So, this we need several decades. That is what I have been telling, next 3 decades do not worry, we will have security related issues, right, and this is because we are now retrofitting security. And when you see that diagram which I have shown quite now very nicely, I think you will all memorize. I will keep on repeating certain things. I believe that if you repeat 7 times, it will at least one time it will sit in your head. So, I will do that, and so it is very important. So, what we have is first the hardware, on top of it is your microarchitecture, and top of it operating system, etc. So, all the other things are excellent, no problem there, but then you have this the hardware, right, a very flimsy, lousy hardware, you are gone, all your excellence goes off, because until finally this is the fellow who is executing your programs, and if there is some stupidity here where anybody can come inside and do something, however good or however best your operating system and compiler and other layers be, if your hardware is flimsy, everything is gone. So, hardware is the root of trust. The root of trust is your architecture, and that we have to be extremely solid, so that you build a secure system. So, the foundation of your secure system is in hardware, right. So, that is why if you start working on secure hardware, already if you work on security you will be boss, and if you work on secure hardware you will be really a boss, okay, right. Let us go into this. What is security from a hardware viewpoint? Right. What is lack of security? Here it is leakage of information. I have some private information, I leak, that is a breach of security. Other thing is, there is an unauthorized gain in privilege. Now, you are a user, you get into super user. After becoming super user, you will do a lot of things, right. So, the two definitions of security today is, what is a secure hardware? A hardware which will prevent leakage of information, because I could gain information even before getting a privilege. I could be an external fellow, right. So, I should have a clear defined mechanism which will prevent me from leakage of information, and there should be a clear mechanism which will ensure that there is no unauthorized gain in privilege. If I am going to ensure these two things, I think we have almost a good secure hardware, correct. So, all that my responsibility to the operating system, to the compiler that are going to execute on top of me is that I see that there is no leakage of information, I also see that there is no unauthorized gain in privilege. See, how can information leak? How can I get unauthorized gain in privilege? The main reason is the processes that are execution. What is a process? A process is a program in execution. The programs that are executed, they do not have what you call as perfect isolation, right. What do you mean by isolation? I share certain resource. For example, why did stack smashing happen? Stack smashing happened because I shared the same stack. The calling function and the called functions shared the same stack. They were not isolated because they were still sharing the same stack. If I take any two processes in the system, correct, what will happen? I share the same registers. So, in an architecture there are general purpose registers, right. When I am executing, I am using the registers. After I finish, or suppose I have a scheduling algorithm where 10 programs are scheduled on the same, 10 processes are scheduled on the same hardware. I execute now, I use the general purpose registers, I move out, somebody else comes in, he also uses the same hardware registers. So, when I am moving out, if I did not erase those registers, correct, the other fellow who comes in can keep reading these registers, correct, and by reading these registers, the information about me can go to the program who is going to follow. Why I can't erase all the registers? I cannot erase all the registers because I do not know when I will be moving out. I am a program who has to execute for 100 seconds. I will be given 100 milliseconds some 100 times, or 100 milliseconds 1000 times, if I have a round robin scheduling, right. What is a round robin scheduling? 100 processes sharing one fellow, each will be given some time, pulled out, next fellow will be put in, pulled out. This is a Robin Hood type of thing, right. So, I execute now, I do not know when I am going to be pulled out. I will be pulled out by whom? Some interrupt will come and pull me out. The operating system then loads the next fellow. Now, whose responsibility is to erase the registers? Operating system's responsibility. But if it does not do, then what will happen? Then the next fellow who comes in can access these registers and get value. You are getting my point, right? So, we cannot ensure perfect 100% isolation between processes as of today in the contemporary operating systems. And since I can't ensure that, there is a sharing of resources, and that basically results in leakage of information. Are you getting this? So, the main reason is memory, right, because memory is one source. Memory in different forms, it can be cache, it can be registers, it can be RAM, main memory, it can be disk, but memory in any form is the one source where I violate the property of isolating individual processes that need not communicate, right, and that is one of the major reasons for a leakage of information. There is also a major reason for unauthorized gain in privilege. There also the calling function and the called function shared memory stack, and that was the reason for that. Is it? Okay. Now let us go. So what are we going to do here? We are talking about memory isolation and we are going to talk about code privilege, right. Privilege in the sense that I can do certain things, I cannot do certain things. If I have some privilege, I can do certain things. If I do not have that privilege, I cannot do certain things, right. So how is that implemented? What is it that the architecture can do to get you that code privilege? What is it that the architecture can do to get you that isolation, memory isolation? These two aspects, in my opinion, if you are thorough, if you have an understanding, I think you can start appreciating security, information security in a better perspective. Okay? So what we are doing to do in the area of memory isolation is, we are going to look at two very interesting architecture, the x86, which is clearly seen in every laptop, every many 99% of your laptop and desktop systems do use x86. ARM, with 99% of the computers today, your mobile phone has ARM processor. So we will look at memory isolation from the x86 perspective and the ARM perspective, I think. And then so what is it that we are going to see in x86? What is so interesting about x86? Why we are all excited about x86 is that we have seen 5 generations. It was existing in many of your previous births, right? Even before you are born, x86 came in, and probably if it exists for another some more time, it can see 2, 3 generations of the same soul coming back and forth from earth. Okay, so it's a very interesting thing. So if anybody wants to understand how architecture has evolved, you have to go and look at history of Intel and AMD. It's very important, fascinating things. Okay, so we will deal about 2 important memory management concepts in x86 architecture, which is the segmentation and virtual memory paging. Okay, I will explain those details, those things in very much detail. And from ARM, we have something called the trust zone, and we will have an ARM trust zone. We will have a demo of a product that we have made in IIT Madras, and we will show you some of the trust zone features there, right. So this is what we will talk about in the memory isolation in this course. And then in the code privilege section, we will talk about interrupt service. Interrupt service is one very interesting and most important thing. So whenever we talk of process isolation, interrupts also come into place. For example, in a round robin scheduling, one process is pulled out and another process is put in, and this pulling out is done by an interrupt service routine, correct. There is a timer interrupt which will stop the execution of the current program, and that interrupt service routine is responsible for putting something in. So I can be a least privileged program, and there can be an interrupt, right, which will be a higher privileged program. So there is a privileged transition when a program is executing and something happens there, and then an interrupt service routine is executing after that. So there is a shift of privilege levels there, and that is why whenever we study anything, interrupt is very important, and any certification we go to prove a system is secure, interrupts plays a very important role. And another important thing about interrupt is that it is very asynchronous. We do not know when the interrupt will come. As I explained to you in that when I move out and another code comes in, why can't I erase the registers and go? I cannot do that because I do not know when I will be pulled out. So the interrupts are also asynchronous events. So that makes interrupt service a very important thing. So whenever we do interrupt service, there are very subtle things in the Intel architecture, in the AMD architecture, in the x86 architecture in general, which will ensure you this type of security. And that needs quite a bit of deep dive into the architecture. No normal textbooks or conventional computer organization course does not teach you that. Okay. And then of course, switching of task. So, I am a privilege 0, high privilege code, then I start executing the low privilege code. What it means, how can I go from a high privilege to a lower privilege or lower privilege to a higher privilege. So, what are the basic safeguards I need to take before I do such type of switching. And then we will also talk about two interesting technologies that have come up. One is the high assurance boot and secure signing in random access memory. We will do it in very great detail at the end of this course, which will stop you from concepts like VMBR, right? The virtual machine based rootkits. How can I handle that is through this. Okay. So, when we study computer organization here is it is not just going to be we are not just going to talk about hardware here. We are going to talk about lot more of operating systems and tell you what is it that is needed in the hardware and how it is existing, so that it handles those issues. So, this is a issue based course rather than trying to teach what the hardware is. Okay, right. So, very importantly, please understand security is no more theory, it is full of practice. Okay, this course will try we are going to give you a lot of programming exercises, and we will do live demo of these exercises, and we are going to develop a small mini kernel for x86 environment, and that mini kernel will be written in assembly. Right? We are going to do assembly level programming, and that will help explore the security features provided by x86 hardware. So, the best way to understand hardware security is to write assembly programs and realize this. Right? Unless you go and work at the assembly level, you cannot have an intricate understanding of the hardware. Right? If you write C programs, then there is somebody intermediate between this C program and this, and you cannot even understand how those things, you are one layer above. So, you have to be very close to the hardware, close to heart of that hardware, and then find out. So, we will be giving you assembly program based exercises in the environment that you would have created in your laptop, and we will do that. And there will be a live demonstration of certain hardware security features in ARM. So, that is what we will do. And this course essentially is sufficient enough, in my opinion, to take you to the operating system and appreciate operating system level security. So, when we start talking about operating system in subsequent courses, and we say that okay, this is how you should realize, now you will have immediate mapping on how you can realize it on conventional contemporary hardwares like your x86 and ARM, right. So, you will have that mapping, some security concept, how do you realize it, what will be the hardware support, you will know how the hardware can support you, and that would be the contribution of this course. So, these are the references, Samuel King et al., Subvert Implementing Malware with Virtual Machines, Smashing the Stack for Fun and Profit, just search you will get this, and this is the Paul Karger and Shell's paper, 30 years later lessons from the multi-security evaluation. So, these three are very important things which will stand as a motivation for you to undergo this course. Okay. So, any doubts in this session I will now take up, else I will go to the next. Yes, doubt, yeah.
If there is a breach of security on some of the higher levels of abstraction, is it possible for the hardware to catch it?
Exactly. So, there is a question is that if I have at a higher level of abstraction like your operating system or compilers at application level, if there is a breach of security, can the hardware catch you? Okay. The hardware is supposed to catch, right, and so for the hardware to catch, so why are you asking this question? So, the answer I should give you is that how is that related to this course, correct, right. So, for the hardware to catch this, it is not the hardware that is catching, the hardware will give you some features. Now, you should use those features intelligently so that you catch it, right. So, hardware will only build you a dam. Now, you have to fill it with good water, correct. So, now for you to catch those vulnerability, you have an infrastructure to catch that vulnerability, right. So, we have put a road and put a gate. Now, it is for you to how to lock and open that gate so that trespassers do not enter. You followed? So, it is for you to put that watchman. We are not putting the watchman for you, right. So, one thing is to understand what the hardware can do for you. The second thing is how you exploit that feature to basically get those things done. For example, there will be notion of a mini kernel. There is something called a G node, a project that is we are also doing at IIT Madras, and some of our funding partners are also involved in that, which is a microkernel based approach. What it does is it gives you a very good isolation between different processes, right, and the hardware. Okay. So, the G node is called a separation kernel in all practical aspects. And what will the separation kernel ensure you? It will enumerate a list of objects. Okay. It will enumerate the list of objects, and it will also give you a way by which you can impose rules on this access to these objects, right. And so, a vulnerability basically comes when I am having unauthorized access to a object. You are getting this, and when I get an unauthorized object access to an object, basically I am violating some access rules, right. Now, this microkernel will give you a way by which you can enforce such rules, so that you do not get an unauthorized access to an object. By that I could, if somebody tries to do it, yes, you can catch, right. Now, as in the course itself, you will be doing some assignments where you try to go and access a memory which you are not supposed to access, and you will be caught, right. So, that is a simple thing I can tell you that will happen in this course, in the assignment that you are going to do, the programming assignment you are going to do, that we are going to demonstrate here, correct. But then beyond that, we give you the infrastructure, and it is up to your intelligence to build it up and use it effectively. Okay. Any other doubts?
Why can't you build a separate hardware for us, like the security software is available? Through the interface card, we are allowing all the attackers. Can stop all the attackers in the hardware itself?
No, but you do not know whether he is an attacker or not an attacker, right. If I know that you are an attacker, I will stop you there itself. I will not even allow you beyond the Ethernet card. I do not know whether you are an attacker or not an attacker, and that is the problem here. I do not know you are genuine or not genuine, because you come with credentials, right, correct. Follow what I am saying. For example, even in the case of stat smashing, which you will be using quite throughout, I do not know what sort of code you wrote. I do not have any way by which whether you are writing normal data or writing an assembly program, but you wrote an assembly program and got access through that assembly program, right.